Hi, everyone. So today we're going to be speaking about oracles and their significance, as well as how we can overcome the limitations created by smart contracts using oracles and the effect that that can have, the positive effect that that can have on our industry. Um, the first thing I think it's useful to understand is the problem we're dealing with. The fundamental problem here is that smart contracts and blockchains can't connect to external systems. This means that the security model they have limits them while providing all those great guarantees we care about in terms of their transparency, reliability, and high amount of trust. This limitation basically means that we can't access important pieces of data, such as market events and other events that we would run a Reddit contract about. This limitation, in my opinion, is what keeps our space in token land. So tokenization is the core use case of blockchains right now, and then the trading of tokens and the movement of tokens, and sometimes the voting either with tokens or on certain things related to the tokens. Now that's not an issue. It's a very good thing, and I think it's seeded our ecosystem with a lot of value that people can then use to use DeFi products and do other great things. But I think our ecosystem really has, and our technology has a lot more it can do, and it can go beyond tokenization to do something truly more valuable. And I think what it would do is it would actually grow the entire pie such that there would actually be more need for tokenization, but you would have contracts, from the derivatives industry, the insurance industry, the trade finance industry being put on a blockchain and being run much more effectively there, and leading those industries to eventually migrate all of their contracts onto the smart contract infrastructure that we're all building. And this is really the future that I think a lot of folks and folks in our space are working towards. This is the type of shift I've seen before. I've seen this shift twice now. You went from programmable money using Bitcoin multisig as its only, a feature addition to moving the Bitcoin around, to these protocol contracts where the contract was in the protocol itself. Then you went to a world where you could write the contracts. This is what Ethereum is very credited, very well respected for. And the truth is they moved the space into an entirely new version of what it could do. The limitation is that what it can do right now is really generate primarily tokens and a few other smart contract things related to tokens. And there's another shift that we really want to make towards all these real world contracts based on market events, based on insurance events, and all those events. I think that DeFi is really what this is. It's an initial beginning of this trajectory where you have people like Synthetics, Aave, BZX, Nexus Mutual, creating decentralized financial derivatives, lending, various insurance products, and these products are getting attention because they're superior in certain forms. But I think there's much, much farther to go. I think the limitations we need to overcome is we need to first understand that all of these contracts I just showed you are actually built using external systems. So they all need market prices. They all need some kind of data to prove that the contract should go to the next state. And this is the body of work that we're involved in. We're involved in how do you take smart contracts beyond tokenization and into a world where they can interact with any external system, whether that's an enterprise system, a piece of data, or a payment system. And that evolution is very important because it'll, I think, come to redefine our space. Now, we basically focus on a multitude of systems and a multitude of chains, and I'm going to quickly run through some of the key points of how we approach this problem and how we seek to solve it. So at the core of our approach is decentralization and the ability to have multiple independent nodes computing and validating data so it meets the high standards of a smart contract. The nodes that are validating that data in our case are of very high quality, and we have systems that assure their quality and that actually float information about their quality. So the more high quality a node is, the more transactions and usage it gets. We focus on high quality data and only generating the type of data that is of a sufficiently high validation to trigger a smart contract. And as well as cryptoeconomic security, where we basically use something called staking to provide a certain amount of guarantees around whether data is delivered correctly. We then apply other security approaches with a defense in depth kind of approach to security. That includes trusted execution environments, zero knowledge proofs, and other approaches. We do all of this with an absolutely amazing open source community of node operators, developers, researchers, and auditors that work with us diligently to make sure that all the right inputs are included in the system and that everything is maintained at a highly secure level. And then we seek to provide all of these inputs and outputs to all the blockchains out there so that a developer can build smart contracts in whatever environment they think is optimal for them. There are certain environments optimal for one type of contract, others for other types of contracts. Generally speaking, the first category of problems we set out to solve, and at this point at a technical level seem to have done a good job at solving, is the avoidance of a centralized oracle. So you don't want to rely on thousands of nodes for a computation and then have a single node that is a point of failure, kind of breaks the whole model, breaks the whole system. All you have to do is attack that single node, and no matter how well written your contract is, it can all fail. So you basically first need to get away from centralization, which we do through decentralization and having multiple independent node operators that compute the validation of data to put it into various chains and allow it to be used by contracts. We actually seek to guarantee that this data gets delivered correctly in our system. So we don't just decentralize and validate multiple pieces of data to guarantee that the input into a contract is at a sufficiently high level. We actually require, we'll soon require smart contracts to make sure that they both are using a good data source and that the Oracle operator, the Chainlink node that's giving the data to them, commits to certain conditions. And those conditions are related to payment and related to reliability. This is partly the replication scheme, a replication of what service agreements seek to do in the real world. And to contrast this with other Oracle solutions, some of them can't access paid APIs, so they have no guarantees of high quality data. And if they don't have service agreements or a capability like that on their roadmap, then it's not likely they'll be able to provide that same high level of guarantee once the data is supposed to be transported. We also apply cryptoeconomic security to this dynamic, once again, through the service agreement, which defines the conditions under which people are both paid and the conditions under which they could end up losing their deposit or stake as a node operator. And this provides an additional level of assurance that the data delivered to a contract is going to be delivered correctly, and that it's something that the contract users and developers can actually rely on the Chainlink network, the Chainlink nodes in a specific Oracle network to deliver data of a certain quality from ideally premium APIs, because they have the ability to interact with premium APIs and already do on a regular basis. Once we've decentralized the Oracle mechanism, we can reliably begin to decentralize the data level. And at that level, we have two models. One model is where data providers actually run a Chainlink node. That gives them built-in signing and the ability to sign transactions into multiple blockchains with pretty much almost no development effort, retaining their current infrastructure and methods of generating data and their entire API infrastructure. And then we have node operators that query data providers that are not yet at the level where they want to run a node. So there's a certain flexibility in being able to include the data providers that want to assure their data at a higher level of security by running a node of their own. But then you also want flexibility in that you can include data providers that don't yet want to run a node, but they do see a reason to provide data to various blockchains. And in fact, every additional blockchain that we add support for expands the universe that data providers can sell to. And that creates a virtuous cycle where a larger universe of users encourages better and better data providers. Better and better data providers and better inputs generally generate better and better applications, which creates a virtuous cycle where more and better applications create substantial justification for data providers to then say, yes, I do want to provide data into this system. A lot of this is available today. You as a smart contract developer can go to feeds.chain.link. You can attain very well validated data feeds from multiple aggregators that are input by extremely high quality node operators at a certain frequency and at a certain level of data quality. And so far we've already seen this jumpstart certain launches of decentralized applications in DeFi and allowed existing applications to either become more secure or very quickly launch additional markets because they don't have to create decentralized infrastructure. They just use decentralized infrastructure that gives them all the inputs they need for that second half of the contract that isn't the core contract itself, but is all those systems that they need to interact with. And in the case of DeFi, one of those main things is price feeds. And that's something that at this point we've done a relatively good job at providing at a high level of quality and security to DeFi applications, such that we've even now had a few people launch with us without having to build an entire decentralized infrastructure. Now, price feeds are not the only input that's important for the growth of smart contracts and their use and blockchain-based applications. So I'm very excited to announce today that we're introducing something called Chainlink VRF. Chainlink VRF is something that we've been working on for a while with with some of our academic partners and some of the most talented people in the blockchain space, to generate a source of randomness as a key input that is also verifiable. So there are a number of applications that use randomness in very meaningful ways to be able to securely exist. And it's one of those inputs that pulling that input from some other off-chain source is sometimes problematic because it's not necessarily built for a blockchain, or using all the capabilities of a blockchain to provide security to the application developer and the user. And so we're very excited to today be releasing the initial testnet version of our Chainlink VRF, and to showcase what some of the things that it can make possible. So as always, I think it's useful to understand the problem we seek to solve in this context, and that problem will begin to inform our discussion about how are we solving it and what are the benefits of making this input the way that we are. Now, I think the first thing to do is to look at what is the use case for randomness. A very common use case is blockchain gaming. So after DeFi, blockchain gaming is probably the largest use case for blockchains right now. Blockchain gaming basically depends on users going to a smart contract that guarantees that the user will be fairly treated, and whatever manipulation happens in a centralized version of that same game can't occur with the user. So for example, the creator of the contract can't manipulate money away from users that deserve to get it according to the contract's conditions. Or if there's some kind of digital good generated by the contract creator can't simply take it away from a user, right? So the guarantees of blockchain gaming are very well suited for users that want to interact with the contract that needs to assure the user that they won't for lack of a better word, be gamed themselves. So they won't have funds stolen from them. Now, some of the most common, or maybe even the most common design pattern in blockchain gaming is the use of randomness. So randomness often generates payouts to users in cryptocurrency which they previously deposited, or it generates digital goods, or any other number of events that basically blockchain games rely on. So even in the initial version of blockchain gaming, you can see that it essentially, the contract, much like DeFi contracts, consists of two parts. It consists of the contract and the conditions of the game, and then it often consists of an input, which is the majority of the time randomness. Now, the design patterns that we see in gaming so far, blockchain gaming so far, sometimes don't deliver on the full potential and end-to-end security that DeFi is now seeking to deliver to its users through the use of highly reliable oracles. One of the dynamics that I think it's worth mentioning, that in certain scenarios, the creator of the blockchain game also runs the random number generation service. So on the one hand, the smart contract and the conditions of the game and possibly the ownership of digital goods is on a blockchain and therefore not gameable. But the random number generation that determines the amount or the value or the relationship between that contract and the user and the cryptocurrency they put into that contract is controlled by the game's creator. Now, this leads to not the certainty, but the unfortunate possibility that there is a chance that the game's creator could have the same problems, either by having his service compromised by an adversary or by compromising it themselves, or whatever collection of problems that might occur. You are once again sitting relatively close to centralized games where one of the key inputs is still in the control of the operator. And this is the core issue, that providing a verifiable source of randomness that can't be gamed and that is outside the control of any interested party, such as a player or even the creator of the game, provides an additional set of guarantees to users. Now, one of the ways that people sometimes seek to solve this, and we're just going to go through a few possible solutions to see how some of them don't necessarily achieve the outcome we want, is they occasionally seek to use an external random number generator and put it on chain through an oracle. Now, this is an approach that we've seen and some folks have taken, and the limitation for a decentralized oracle system in this context is that a random number generator fundamentally needs to create random numbers. So the various oracles that would query it wouldn't get the same result. And so sometimes people find themselves using a random number generation service and some kind of oracle mechanism possibly made by somebody else. This, unfortunately, also doesn't provide the necessary level of guarantees, because now they're exposed to any kind of adversaries that gain access to the random number generator. And in the case of cryptocurrency, it's quite attractive to them because of the immutable nature of taking cryptocurrency that doesn't belong to somebody. It's much tougher to get that away from them. And so an adversary that compromises off-chain random number generator may, would be able to get the cryptocurrency that's not theirs from a contract and essentially steal it from users. Likewise, there's some additional surface area that's created by passing it through an oracle. Having a decentralized oracle that going to a random number generator without any additional capabilities like Chainlink VRF has is a difficult and limiting proposition. It sometimes could even increase surface area. Likewise, some people seek to use the properties and the data already on chain or the data generated by a blockchain to generate the randomness they need. That also creates limitations where miners could censor the outputs of a chain such that smart contracts could have something stolen from them essentially by miners. Conversely, Chainlink VRF is something that provides verifiable randomness. So what that means is that a Chainlink, even a single Chainlink node providing verifiable randomness, cannot be malicious. It receives a seed from the contract, and the only thing that a Chainlink VRF node can do is not respond. If it responds, the signature and the proof that it responds with based on the seed that was given to it by the contract cannot be biased, cannot be gained by the Chainlink node operator, and as long as the smart contract is built with the proper ordering for the use of randomness, you now have a source of on-chain verifiable randomness that is something that users can rely on and smart contract developers can rely on. Likewise, users can also provide seeds. So if someone is concerned that a smart contract generator or user or developer themselves is providing a seed, then users can take part in the providing of a seed by helping generate it and even using multiple seeds. So this essentially means that you have a source of randomness that's completely proven to, cryptographically proven to be unbiased, and as long as it's provided, it can be relied upon to properly settle transactions and generate digital goods and do everything that randomness needs to do on chain. The benefit of Chainlink VRF is that it's built to use the unique capabilities of blockchains to verify that proof and verify those signatures, which is something that, as far as we can tell, no other randomness generator does. The point here is that even a single Chainlink node is enough to provide these guarantees, and it once again can't be malicious. All it can really do is not provide an answer. To improve those availability guarantees, we then seek to create a system where we have more nodes and where we have multiple Chainlink nodes providing that randomness, and as that amount of Chainlink nodes grows, you have a greater and greater amount of randomness kind of availability. So the chances that any one node doesn't respond doesn't really affect the liveness. But once again, the key property of verifiable randomness is already achieved, even if only one of those nodes provides it correctly. Threshold signatures and our application of threshold signatures to create threshold VRF is something that will really help here. That's something we're working on very heavily at the moment, and we know that it's applicable to VRF as well to basically scale up so that thousands of nodes are providing availability, even if only a portion of the nodes actually need to provide randomness or agree on, or basically send some kind of randomness into the contract. In addition to the use of smart contracts, in addition to the use of these verifiable randomness signatures and proofs, we also use staking. We will use staking to basically prove or help prove that there will be a loss for a node operator that doesn't generate the proper randomness. So there, in addition to the fact that even a single node providing this proof is providing ungameable, unbiased randomness, they will also have very strong incentives to provide this randomness consistently. And the greater the fees that users pay for the randomness, it's likely that the greater the amount of stake that node operators put up to guarantee their availability is something that would also increase. So basically, service agreements and the use of staking is also applied to Chainlink VRF to provide additional guarantees beyond the cryptographic guarantees, the availability guarantees, and now the crypto economic guarantees. This is available today. You can go on our documentation and use it on testnet today. We're still in the final stages of security review, and we seek feedback and any ideas about how this can be improved or how it can be properly used or how it can be properly improved to make sure that it applies to all the relevant use cases. One exciting example of the use cases that could benefit from this is PoolTogether, and we're very lucky to be working with them as one of the initial users of Chainlink VRF. PoolTogether is a no-loss savings game where it encourages people to save by generating interest that then goes to a single winner. In their case, they'll be using Chainlink VRF as one of its initial users, and we're very excited to be working with them and to be able to provide to them a verifiable source of randomness that genuinely gives them and their users assurances that their system is properly making payouts to their users. And the idea is that these assurances should increase the amount of users that use blockchain games in general and applications like PoolTogether, once again making smart contracts and blockchains about something more than tokens. There are tokens obviously involved here, but the point is that blockchain gaming, with the help of a good randomness mechanism, can evolve and can grow much faster, in our opinion. This is just one of the many inputs that we're working on providing. It's one of the more exciting ones because it touches so many blockchain gaming startups and companies that we've already talked with. And we know that highly verifiable randomness is an extremely important part of how they seek to present themselves to users and how they seek to provide their guarantees. And we plan to continue providing a multitude of different inputs and outputs into various blockchains that can benefit from things like verifiable randomness, data, and payment systems and all these other inputs and outputs. If this is something that's of interest to you as a developer or as somebody who would like to collaborate and build oracles together with us, it's a definite fact that we're looking for extremely smart, hardworking, and globally distributed people that are interested in solving this problem. We're adding members to our core team now, and we have a number of other great inputs and outputs and innovations that we're working on, both from the security point of view, the basic cryptographic primitive research point of view, and even just from the software development point of view. So if you're interested in these problems and you see value in helping solve them like we do, we're growing our team, and we'd be very excited to speak with you about helping take smart contracts into the next stage of their evolution. Thank you. Hello.
Hello. Hey.
Hey. Hi, Bobby. How are you?
All right. So hi, everyone. My name is Bobby. I'm the co-founder at CoinGecko. I'll be the host for the Q&A session of Foundations Consensus Distributed. For those of you who are not aware of what we do at CoinGecko, we're the largest independent crypto data aggregator. We've been operational since 2014, and we track over 7,000 tokens from 400 exchanges. Every quarter, we publish a crypto report and have an API that is used by hundreds of top crypto projects. I've got a few questions prepared for you today, Sergey. So let's jump right straight into it.
Great.
Yeah, congrats on the launching VRF. I'm going to ask a bit about the VRF. What's the significance of placing trustless randomness on chain? How does Chainlink approach placing randomness on chain?
So I think the significance is really that there's an entire category of applications in in our ecosystem under the heading of blockchain gaming, and it's the second largest category, I think, after DeFi. And in certain cases, if you look at transaction volumes or the amount of transactions, if not the overall value, then you might even consider them the largest category. And one of the most important input that this category of applications needs in the form of highly reliable, verifiable, provably fair randomness is something that application development teams are struggling to build. And in my experience, when application development teams spend their time building infrastructure, it limits them and the use of their limited resources to build the best application they can. And the best, most successful DeFi development teams that we work with, they're thrilled to have an oracle mechanism that takes a certain problem off of their plate and allows them to redistribute those technical resources towards building a better user experience for application or launching more markets. So I think the significance is that if there's a piece of infrastructure that suddenly gives blockchain gaming developers back 20, 30, 40 or more % of their time because they don't have to build that infrastructure, and it also provides superior guarantees to their users and to other users that would compare their system to a centralized gaming platform of some kind, then it allows those teams to build something much better, expand what they've built, and it also allows the users that they have to grow just by virtue of being able to provide the security guarantees that smart contracts seek to provide. Because smart contracts, I think, are only as attractive as the guarantees they provide. And if the guarantees they provide require verifiable randomness, which I think in many cases in the blockchain gaming space they do, then we hope that can be a catalyst for that part of our space to grow, and to grow that collective pie that I showed before. Blockchain gaming, I think, is a substantial part of that.
Nice answer. Do you guys have any plans to have Chainlink added on other blockchains in the near future? I know you guys recently launched on Tezos, but what's the plans for other blockchains?
Yeah, we have an internal framework right now that we use to add more blockchains. We at some point plan to open that and to create some amount of incentives for blockchains to integrate with Chainlink and for people to build those integrations even in our community. We are speeding up the amount of blockchains we're integrating. So it's a delicate and complicated procedure. We're very lucky to work with the core developers of many of these chains. But I think as the amount of inputs that Chainlink provides access to, like VRF, like price data, weather data for insurance, any number of other inputs as well as outputs, I think the value of integrating Chainlink into various chains will also increase. And therefore, there will be more reason for the core developers of those chains to also see value in integrating Chainlink and to work closely with us. Right now, I think the amount of chains we're in the process of integrating or working on integrating is in the double digits, and it's going to be I think it's going to be at a faster pace as we iron out and systematize and eventually find a way to allow the community and the respective communities of each blockchain to, with a greater and greater degree of efficiency, integrate Chainlink into their chain. And then likewise, all the fees from each respective chain then contribute to the pool of fees financing the security of any one resource like Chainlink VRF, such that more fees would generally suggest that people would be willing to put up more stake to increase the guarantees, right? So more usership would generate more fees, which would generate more stake, which would generate more security for that specific input, and likewise with many of the other inputs. So I think that's actually a virtuous cycle where as you go to more chains and as you get more users, the resources of those users goes towards providing either additional nodes or additional reasons for people to put up more stake, or additional or better data providers. You know, I'm very glad that CoinGecko is one of the data providers that we work with. We're very happy about that, and that's kind of I think how that evolution looks in general terms.
What's the importance of data quality in DeFi? How does Chainlink provide this high quality data?
Well, Bobby, I think you know the importance of data quality in DeFi at a very high level. I think people unfortunately assume that data aggregation and the methodologies related to providing an accurate price that covers all the exchanges that people want to cover and eliminates various categories of risks is some kind of, either they don't know about that problem, which to me suggests a serious issue. Let me put it that way. And ignoring the data quality problem is a serious issue, which I don't think that the centralized systems or hedge fund traders that use your system would do, because they are in such dynamic markets that they would experience a loss very quickly, right? I think that the nuance is that data quality is at this point slightly underappreciated, and people believe that they can maybe just make a data aggregation service by pulling from 4 or 5 exchanges, which I think, even given your experience, you know that is just riddled with multiple failures that you know of from your own experience.
Yep, all kinds of outlier issues, API going down from major exchanges, weird data coming out from all these different exchanges, so all kind of things. Maybe we have time for one last question before I wrap this up, this Q&A. So I'm going to ask this question. Chainlink has been quite focused on crypto pricing data, but Chainlink is actually built to support all kinds of data. How has development in other forms of data been so far? What sort of data besides crypto data is showing interesting growth in the Chainlink ecosystem?
Yeah, I think the categories that I see growing, as you said, DeFi, I think we're excited to see blockchain gaming get a high quality input and start really hopefully growing more and more and expanding because of the reasons I mentioned earlier, more technical bandwidth and better guarantees to users. I think another one is insurance. So insurance is something that moves generally slowly in the world in general. But I think that insurance products are really on a next level in the blockchain ecosystem because they provide so much trust guarantees to people that are not provided by traditional insurance. And I think it's just taking time for some of it to migrate. But generally speaking, you're right that Chainlink is really a general purpose decentralized Oracle kind of network and framework that is initially being applied to price data for DeFi because that's a fast growing space. And I would even like to think we can accelerate how fast it grows with the appearance of high quality oracles and more data points with the help of great data aggregators like yours. And then after that, I think gaming, and after that, if I had to guess, I would say insurance. Those would be the 3 categories, which Chainlink is completely set up to support. In insurance's case, I don't think it'll be reference contracts because insurance has very specific requirements about a specific single piece of data related to a specific policy. And that's where something like market.link or other systems where you can define very clearly about a single input that you need, but maybe other people don't need. That's what we internally call the direct model. So right now we're doing very well on the reference data model where we're able to provide high quality price data to the DeFi contracts that want to be triggered off of that. Randomness is its own entire set of problems. And then the direct model is probably going to come from insurance where I want to make a direct relationship with some IoT sensors and nobody else wants that data. And that's something we've already discussed with a number of people, and there's things that are slowly moving towards production using that direct model. But once again, it's in an industry that moves slower.
Cool, very interesting applications. I guess that's all the time that we have for Q&A for today. I'd like to thank Sergey for taking the time to present to us and answering the questions that we have prepared for today. So I'll hand it back and move on to the next stage of foundation.
Great. Thank you very much, Bobby. Good chatting with you again. Thank you.